So the phenomena of attracting the magnetic substance like iron, nickel, cobalt, etc. The body possesses a property of the magnetism is called magnet. A magnetic pole is a point near the end of the magnet where magnetism is concentrated. So these are all the properties of the magnet. Already you know the property of the magnet. So now we are going to see that what are the properties of the magnet. So Earth is a natural magnet. In this region, magnet is which exerts the force on the other magnet and other objects made on the iron or the magnetic field. So definitely the magnetic materials are attracted or repelled only the magnetic materials. It is not attracted or repelled the non-magnetic materials. So now we are going to see the properties of the bar magnet. First one, a freely suspended magnet aligns itself along a north-south direction. Unlike poles attract and like poles are repel each other. So magnetic poles always exist in pair. Poles cannot be separated. A magnet can induce magnetism in other magnetic substance. It attracts magnetic substance. So repulsion is the surest test of magnetism. So magnet attract the iron rod as well as the opposite pole of the other magnet. Therefore, it is not sure test to magnetization. But if the rod repelled with a strong force of a magnet, then rod is truly magnetized. So now we are going to see that in a animation. Okay. So I am going to show you that how the magnets are having that property. That what we are going to see in the animation. Okay.
The other property. Students, poles of a magnet are located.
So see that poles of a magnet are located near the ends. The attracting power of a magnet is maximum in that only on the pole region. That is 2 ends and minimum at the medial. So the magnetic strength is at the maximum at the 2 pole regions and minimum at the center regions. Now we are going to see the property of the magnet. First property, when iron fillings are spread over the paper, you can use the bar magnet. That bar magnets are placed on the iron fillings which is spread on the paper. The iron fillings are spread here. Now you can place the bar magnet. Bar magnet can place on the iron fillings. You know that when bar magnets are placing on the iron fillings, it will attract. So when iron fillings are attracted in the bar magnets, you see that most of the iron fillings are cling near the ends of the magnet, while there are very few iron fillings in the mid side of pins at the middle. Okay, so only the fillings under that pins are mostly attracted in the edges or the north and south pole region. Okay, the 2 ends of the magnet have the greatest attracting power. So they attracts more iron fillings or pins. So more power at the ends. That's the one property of the magnet. Next thing is, when the magnet is suspended in a thread, you can take that one bar magnet. Fully suspended magnet always points in the north and south direction. That is another one property of the magnet. So bar magnet shows the north and south direction. That's the suspended through the thread. So thread is a non-magnetic material. So the magnet shows the north and south direction. So that is a property of the magnet. Okay. So it's another one property. So it has 4 or 5 properties. So north pole shows the north and south. So this is the north and south. Next property. So now we are going to see another one property. When bar magnet, again you can suspend it through the thread. So definitely the magnet will come to rest in the direction of north and south. So this is the property of the magnet. Suppose you are making the disturbance or you are changing the angle of the bar magnet. You are disturbing the bar magnet. So after you disturbing the bar magnet, again it will come to rest in the direction of again north and south. So the magnet always points to the same north and south direction. So that's the property of the magnet. Then another one property of the magnet. So this is the 4th property of the magnet. Like poles repel and unlike poles are attract each other. So like poles, when the north pole of the magnet brought close to the north pole of the another suspended magnet, the two magnets repel each other. But when the south pole of the magnet is brought close to the north pole of the another suspended magnet, they are attract each other. So this is another property. Then fifth property. So now you can see that magnet is suspended on the thread. So it has two poles, north pole and south pole. Always it shows the direction also, north pole and the south pole. So whenever you disturb that, again it will come to rest in the direction of north pole and the south pole. So when you brought near that north pole to the south pole, it will attract each other. This is the property of the magnet. It will attract. So north pole attracts the south pole. Okay. Suppose you are brought near the south pole to south pole, they will repel each other. So the two south poles are repelling each other. So this is the property of the magnet. Okay. Then last one, see that when the north pole and south pole of the south pole of the ball magnet, each magnet its own magnetic field. It is depending on the strength of the magnet. The effect of a magnet is felt in a certain region around a magnet. See that when we place the needle near the ball magnet, the compass needle swings and then rest in the different direction. Already you did the experiment in 10th standard. So when you place the compass box near the magnet, it will show the deflection. So see that when you place the center, it's a minimum, so it will show the north and south direction. Okay, it's from the center place, so it shows the north and south direction. So when you move the magnet from north pole to south pole, you can get the magnetic lines like this. So near the north and south pole, the magnetic lines of force is very large. The region around the magnet in which its influence can be felt is called magnetic field. The magnetic field is stronger near the magnet and decreases with the increase in distance from the magnet. So another property, you can able to see the magnetic lines of force. So place the bar paper on the table and spread out the iron fillings. So the bar magnet is placed on the white sheet. So iron fillings are placed on the white paper. So it is spread over all the side of the paper. Then gently we can take the table. Just we can tap the table. So it will show the magnetic lines of force. See the magnetic lines of force. It is a perfect line. The iron fillings are arranged themselves with a definite pattern. So near the pole region, the lines of force are maximum, but in the minimum in the center region. So this is a property of the magnet. Okay. So these are all the properties of the magnet. And last one is the north and south pole of the magnet. So in a magnet, north and south poles exist in a pairs. Always exist in pairs. So they cannot be isolated. You are not able to separate that. So when you break that magnet into two pieces, again it will be separated into north and south pole. So two magnet will become two magnet. So again that into separated into another two pieces also. Again it will become a four magnet. Again it has the north and south pole. So all the magnets has the north and south poles. So always it's appears in a pairs of north and the south pole. You are not able to isolate that. So on breaking the piece of that magnet further produce a large number of magnets with both the poles at the ends. So you are breaking that more than 2, 3, 4, whatever it is. Poles of the magnet cannot be separated. Always exist in pairs. Okay. So uniform magnetic field and non-uniform magnetic field. That uniform magnetic field of the diagram is indicating like this, that blue color line. Uniform field perpendicular into that plane means you are indicating that into mark. uniform field perpendicular and emerging out of the plane of the diagram. So these are three methods of indicating that how that fields are acting in the plane region or the perpendicular region, or it is comes out. So using that symbols you can find out. Okay, so current loop as a magnetic dipole. So dipole moment. So dipole moment and magnetic charge field, electric field, everything we studied in the first lesson. First lesson we study about the charges, what is the property of the charges and everything. So when you compare that lesson, first and the third lesson, all the properties are same. So when you see that Coulomb's law, so electric field intensity and the property of the charges, everything is analogous with the magnetic field. So magnetic field electric field ரெண்டும் ஒரே மாதிரி தான். அந்த சார்ஜ் வச்சு நம்ம என்னெல்லாம் டெரைவ் பண்ணணுமோ அதெல்லாம் அப்படியே இங்கே வரும். நீங்கள் ஃபர்ஸ்ட் லெசனில் இருக்கிற கொஸ்டின்ஸ் எல்லாம் படிச்சிருந்தீங்க அப்படின்னா அதில் சார்ஜ்னு வர இடத்துல எல்லாம் மேக்னெட்னு போட்டீங்க அப்படின்னா அங்கே எலக்ட்ரிக் ஃபீல்டுக்கு பதிலாக மேக்னெட்டிக் ஃபீல்டுன்னு போட்டீங்க அப்படின்னா நீங்கள் தேர்ட் லெசன் படித்த மாதிரி. அப்போ நீங்கள் ஃபர்ஸ்ட் லெசன் தரவாக இருந்தீங்க அப்படின்னா தேர்ட் லெசன் ஈஸியாக படிச்சுக்கலாம். ஸோ இங்கேயும் பார்த்தீங்க அப்படின்னா மேக்னெட்டிக் டைபோல் மூமெண்ட். ஸோ மேக்னெட்டிக் டைபோல் மூமெண்ட் இஸ் டிவைட் as the m equal to I into A, where I is the flow of current, A is the area. So when we look at the one side of the tube carrying current, if the current is in anti-clockwise direction, that is so to be behaves like a magnet in a north pole. So you are taking a one coil, means when the current flowing through a clockwise direction, that nearer end one end is behaves like a north pole, other end is a south pole, but in an anti-clockwise direction. Clockwise means it will show that one property, anti-clockwise in opposite direction. Okay, so this is a magnetic dipole and magnetic dipole moment. So it is a solenoid. Solenoid means it's a bar magnet. So when the solenoid is current is flowing through a solenoid, it will behave like a bar magnet. That is